Hi guys, I'm Noemi Kluz. I'm robotic engineer and you are on my channel Robotization and New Technology. And I will start the movies. I have for you few movies, few videos about robot programming. It will be very basic knowledge. And the first part is about TCP. So we today will speak about TCP. What is TCP? TCP is Tool Center Point, and it's default on the flange of robot, so at the end of the last X. And why it's important to have it in correct place? Because if it will stay on the flange, for example, and you will move the robot from one X, for example, you can move fifth one, and you want linear, for example, move. Then your tool will not be on the linear part. Like I have this pen, and this is the end of my tool, and this is my X. And if I want to make a linear point, and I will have here the coordinate system, then my point will move like, for example, if I will make some moves, it makes this movement. I have it. There will be linear, but not at the end, and I want this point to have the perfect line. So you need to change coordinate system to this point, and then you will move this point in the line. Like, doesn't matter what is happening here, but here it will be on line. Yes. So that's why it's important, and to have a coordination system good for your moves, because if you will not change it and you have any special gripper, for example, then you will not know, and operator will not know what will happen and where the robot will move. So that's why it's important. Of course, if you have, for example, chosen user frame or word frame, because if you move just joints, then it doesn't matter, of course. But if you move in coordinated system, then yeah. And for example, what is important here? You have few methods to put the coordination system at the end of your robot, and first of all you need to choose where do you need this coordination system, because it depends on gripper. For example, if you have welding tool on your robot, then it will be at the end. So for example, it's my welding tool, and my coordination system, even if it's not like that exactly. For example, my welding tool is not straight, it's something like that. So your normal coordination system is here like this one, but it's broken and you want to have it here to know how you weld, and to have the easiest option for using, for example, weld coordinations, like which axe you need to push to go in a way which you need. So you will choose, like, for example, Z axis, and then you choose maybe X and Y. But it depends on you. But for example, if you have any gripper like hand or something, you will choose the point somewhere at the end, at the center. If you have spot tool and you have something like that, now you see it well, you will have, for example, on the one part, like maybe here, and the Z might be here or here, depend on how you prefer or what is needed, and like that. So how you can do this? There are a few methods. For example, there is a 3-point method, and what you need to do, I will take it one more time. This is my tool, and this is something what I have, like any maybe stiletto or something what have the pointed end. Maybe in my way it's not pointed, but you can imagine that it is. And you have say three moves, 3 points actually, but at the end of this part, and it needs to be from 3 angles. So for example, I go by my tool from one side, I save. I go from the next side, I save. I go from the third side, I save. And then coordinates will count, and you will have it on the right place. If you want in the special way have coordinates, like you need to choose where is X, where is Y, and where is Z. You need to use 6-point method, because you also check the points where is the end. Like first 3 points are the same like in 3-point method, but the rest of them there are the you need to show the robot where will be X, where will be Y, and it will count Z, of course. That is second method. And also there is direct list method. Direct list method is if you have counted or measured where it will be, then you can directly write coordinates, and it will work. Yeah, so that's the third one. There are also another one, but these 3 I think are used the most often. Yeah, and I think that's all. If you mean TCP point, yes, it's important to make it as close to the reality as it's possible. Other way, if you don't do it correctly and you move, for example, if you turn X and the point end point should be in place, like if you have correct, it will, for example, turn like that. But if you don't have correctly saved, it will make circles or something like that, because the point will be in place, but it will be wrong point, so your end of the tool will turn also. I hope it helped you. The next part will be about frames, so see you next time, and have a nice day, have a nice evening. Bye.